Hello, and welcome to the next lecture in our Foundations of Music series. In this lecture, we will be going over time signatures and beaming. We have gone over these in a previous video, but in this video we will be discussing some of the finer details and nuances involved with beaming and time signatures, as well as how they are related. First, here is a quick review of some of the material that we covered in our previous lecture. Here we have seen a variety of different kinds of time signatures, but one of our focuses this time will be how to differentiate between time signatures that seem similar. For example, here on the left I have 2-4 and 4-8. What do you think makes these signatures different? And on the bottom right, I have just a brief little key to explain what those C symbols mean in that group of time signatures. The normal C, we call that common time, and that is the same thing as 4-4. Because 4-4 is the most common time signature, sometimes you will see just the C and it refers to the most common time. If you see a C with a slash through it, that means cut time. It is also 4-4, but it is twice as fast. You do not necessarily need to know cut time and common time. You are likely not to see it on any of your future assignments, but it is good to know the information is available to you if you need it. Here is again a review of time signatures for anybody who feels they may need to brush up. The top number, again, tells us how many pulses there are in a measure. And this can be any number. It could be 4, 3, 5, 8, 11. The top number can be any number because you can have any amount of pulses in a measure. The bottom number of our time signature translates to the type of note that represents the pulse. In 4-4, the bottom number is 4, and that correlates to the quarter note. Another way to look at this is the bottom number tells you how many of this note would fit in the most common time signature, which is 4-4. In the bottom one, we have 3-4, which tells us we have 3 pulses, and the bottom number is 4, which tells us that the quarter note will represent the pulse. Here, this slide demonstrates the key to understanding the bottom number. Again, this was in a previous slide, but I have it here just in case anyone needs to brush up on it really quickly. Unlike the top number, which can be any amount, the bottom number of a time signature can only be so many numbers. It can be 1, it could be 2, 4, 8, 16. You'll notice that each one is doubled from the previous. 1 doubled gives you 2, and if you double that, you get 4, and if you double that, you get 8. And then 16, and then theoretically, you could have 32 and 64. And each of these correlates to a type of note. So 4-1 would be a whole note. 4 whole notes in a measure. 4-2 would tell us that there are 4 half notes in a measure. 4-4 gives us 4 quarter notes. 4-8 tells us there are 4 eighth notes per measure, and 4/16 tells us that there are 4 16th notes in a measure. Now we will focus on the difference. While you only use one time signature at a time, sometimes you will find that multiple time signatures may work for the same music. In this top example, I've omitted the time signature. We have 2 quarter notes in the first measure and 4 eighth notes in the second measure. There are 2 possible time signatures you could use for this type of music. One possible time signature is 2-4, This tells us that there are 2 pulses per measure and that each pulse is represented by a quarter note. Another option is 4/8. This tells us that there are 4 pulses per measure and each pulse is represented by an eighth note. However, as we know from our rhythm tree, you can fit 2 eighth notes into 1 quarter note. So by having 2 quarter notes in a measure, you by default will also have 4 eighth notes in a measure. So it might seem like 2/4 and 4/8 are the exact same. But you will want to use one over the other, and we will explore how you know when to use one over the other. The first difference is in how you would count them. Again, 2/4 tells us that there are 2 pulses. So we are only going to count 1, 2. Everything in between that will get divided and we'll use and. So here in this first example on the top, we have 1, 2, 1, and 2, and. In 4/8, we have 4 pulses. So if we count that with 4 pulses in mind, we would say 1, 3, 1, 2, 3, 4, where each eighth note is treated as its own individual pulse because we must have 4 pulses. The second difference has to do with beaming and will help us learn more about some of the finer details of beaming. I intentionally left the examples unbeamed up till this point because I did not want to add into the confusion. Now we can see on the bottom right, the 2/4 bar has beamed eighth notes and the 4/8 selection has unbeamed eighth notes. And before moving on to explain that, we have a brief overview of beamings once again. Remember that beaming can occur on any note that uses a flag. So you will not use beaming for half notes and quarter notes and whole notes, but you will use beaming for eighth notes and 16th notes because they have flags. There's a statement in this slide. It was in the previous lecture that had this slide, but I've outlined it in red because of how important it is going to be for us today. And the slide says, it helps to show what pulse these smaller note values belong to. We're going to explore this statement. So, beaming helps to show what pulse these smaller note values belong to. Before explaining how beaming helps to show the pulse, try to guess which of the following examples is the correct way to beam eighth notes in a measure of 3/4. I have here on the right 5 different ways that you might see 3/4 beamed. Only one of them is correct. Remember, the time signature is telling us that there are 3 pulses per measure and that the quarter note represents the pulse. Which example do you think is correct? If you chose the middle example, you would be correct. The middle example is the correct way to beam in a measure using 3/4 as a time signature. Why is this? I have here 3 bullet points that may aid you in understanding why this is. Beams connect notes within the same pulse. Beams do not connect across pulses. Beams help show where the natural emphasis occurs in a measure. To demonstrate what we mean when we say that beams connect notes within the same pulse, we will break down the provided example into 3 steps. So on the right here, we have a measure of 3/4 with 3 quarter notes. We know that there are 3 pulses. So first, I'm going to identify how many pulses there are, and what represents the pulse, and I'm going to write down the pulse above each note. So 3/4, and I have 3 quarter notes, so above it I have written 1, 2, 3. Second, identify where these pulses are when you have notes smaller or other than the quarter notes. So the first measure has 3 quarter notes, and the second measure has 6 eighth notes. I know that there are 2 eighth notes per quarter note, so I've boxed each set of eighth notes to relate to the quarter note or pulse that it belongs to. And you can see the numbers are still there to identify the pulses, 1, 2, 3, and there is a box around the eighth notes below the numbers, which tells us which pulse each eighth note belongs to. Once I've set the boundaries for each pulse, I'm going to use beams to connect all of the flagged notes within the same pulse. And you can see that in the green box in the bottom right. Now that we understand this a little more, we can look at the very first example again. So here I have 2 examples with 2 quarter notes followed by 4 eighth notes, but I have taken off the time signatures. Which time signature belongs to which of the examples? Do you know? Here you can see the correct matches. Did you guess correctly? One way to do this is by reverse engineering the correct time signatures. The beams in the first example are contained to 2 segments of the measure, while the second example didn't have any beaming. This tells us that the first example had 2 pulses, while the second example had 4. From there, we know that 2/4 is a time signature that tells us to use 2 pulses, and 4/8 is a time signature with 4 pulses. The following example has been taken from a recent assignment. We are going to apply what we've now learned and see how this can be done with more ease and efficiency. I've written the 3 steps down, each with a different color, and we are going to go through the steps one at a time. The empty stabs below the examples are going to be where we fill in the correct answer. The goal is to rewrite the following rhythms by beaming all of the notes together in the correct way. The first step is to find out how many pulses there are per measure. To do that, we would look at the time signatures. First, we have 4/4, so there are going to be 4 pulses with the quarter note representing each pulse. The second one is 2/4, so we have 2 pulses with a quarter note representing each pulse. And the bottom example is in 3/4, so we will have 3 pulses represented by the quarter note. And so first we are going to go through and number each pulse so that we can better identify it for beaming later on. You can see that some of the pulses I've put in parentheses. For example, the very first note of the 4/4 section is a half note. A half note contains 2 quarter notes, so it carries over through the duration of beat 2. So you have 1, 2, which is contained in the half note, and then 3, 4, with 1 being on the half note, 2 also being inside the half note, 3 is the first quarter note, and then beat 4 falls on that first eighth note. Now that we've counted out all of the pulses for each example, we're going to find out which pulse each note belongs to by drawing our boundaries or boxes. Here we can see in the green boxes which pulse each and every note belongs to. Again, when you have a half note, I've drawn an empty box to represent the hypothetical beat 2. After you've figured out where each pulse is and which note belongs to each pulse, we're going to beam every flagged note within the same pulse. So if you have flagged notes inside the same box, they will get beamed together. And that will look like this. This should make sense now. I'm going to hold it here so that you can see each example and how the beaming worked. Okay. This time, I've removed the time signatures. The beaming is correct and the bar lines are correct. But can you guess which time signature each line is using? Again, this example was taken from a previous assignment. Here we can see the first example, numbered 5, is in 3/4. Number 6 is in 3/8. Number 7 is in 2/4, and 8 is in 3/2. A couple things to note in this slide. For number 6, when the time signature is 3/8, you'll notice that all 3/8 notes are beamed together. You will sometimes see this. You can either beam all of them together, or you can keep each of them separate. But you would not see one isolated eighth note and then the other two beamed. That would be very unusual. Another thing to note is with number 8, the time signature is 3/2. This could also be seen as 6/4, or having 6 pulses with a quarter note representing each beat. But if we reduce that to its most common form, like you would with normal fractions, 6/4 can divide down to 3/2, which gives us a simpler and cleaner feel. And when you listen to music in 3/2, you will find that it feels more like it is in 3 than it is in 6, such as a waltz. 1, 2, 3, 1, 2, 3. If it was 6/4, it would go more like this. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And that is a little too busy. Remember, we want to be as efficient as possible. Here I have a special note on beaming that I think a couple people get a little tripped up on. Pay special attention to how beaming occurs between a dotted eighth note and a 16th note. The number of beams that extend from a note's stem must match the number of flags. Because of this rule, one beam extends from the dotted eighth note and connects to the 16th note. A second beam extends from a 16th note, but it does not connect to the dotted eighth note. Here in the red box, I have what it looked like without beams, and then in the green box, you can see what it looks like when you beam it correctly. Secondly, beat 2 of the example below has 3 notes in it. All 3 notes have flags, and so all 3 notes will be beamed together because they all belong to the same pulse. Because all 3 notes have at least one flag, we can start by connecting all 3 notes with one beam. Because the two 16th notes both have 2 flags, they can be connected with 2 beams, and there is no need to extend an unconnected beam towards the 8th note. You can see that here with the red box showing what they look like without beams, and the green box showing what they look like when beamed correctly. The following beat is the exact same method, but it is a mirrored version with 2 16th notes followed by an 8th note. And that covers many of the finer details and rules for beaming and time signatures. You should feel fully equipped and confident in identifying time signatures by how the measures are beamed, as well as be able to beam correctly yourself. I've also included a rhythm tree here because I think everybody should have a rhythm tree. Do you have a rhythm tree? Rhythm trees are very helpful. Rhythm tree.